Good morning to all. Today we are going to see about webinar that is 8086 system bus structure. So this chapter will include the detailed pin configuration of 8086. The various signals and various modes of operation can be studied with the help of this unit. Today we are going to see about 8086 signals. This is the pin diagram. Usually the pin consists of 40 pins. Among the 40 pins, few pins were given as address lines and few have been given as a data lines. So this we already aware of 8086 will have 20 bit of address lines and 16 bit of data lines. So some of these signals will be mentioned as minimum mode and maximum mode signals. That is the two kinds of operation of 8086. For example, if we consider in minimum mode, so the pins range from 31 to 24. So the highlighted pins will comes under minimum mode. So these are the minimum mode pins. And when this 33 pin will used to designate whether the 8086 will operate in minimum mode or maximum mode. Depend upon this input, the 8086 will prefer a minimum mode or maximum mode. These are the maximum mode signals. From 32 to 24, you are going to give two signals, minimum mode and maximum mode signals. So first one, as I said earlier, the 8086 will have a 16 bit of address lines, 20 bit of address lines and 16 bit of data lines. The address lines from AD0 to AD15 will be act as address or data lines. During the first part of machine cycle, it will act as address bus. From remaining machine cycle, it will act as a data bus. The address or status signals A19 to A16. These signals will be used in input-output operations. So these are the status signals from S3 to S4. Depends upon these input, the functions will be chosen as a designated segment will be chosen. For example, if the status signals of S3 and S4 will be 0, 0, the extra segment will be taken into consideration for operation. So for example, if the S3 and S4 value will be 1, 1, the data segment value will be taken into consideration. Similarly, it depends upon the input of A0 and VHE. VHE is nothing but bus high enable. Depends on these two inputs. What are the bytes to be read? For example, if 8-bit data will be present means odd or even address or lower bit or upper byte, whole word or what have to be read during this operation. That have to be decided with the help of these two pins. So first one is your read. This signal is used to read the data from memory or input-output devices. Next one is a ready signal. Whenever the signal will be low, the 8086 enters into a wait state. So for example, if it's for currently it will doing some other operation means this signal will goes to a low state. So it will wait for a particular duration. Once the operation will be completed means again the signal will go to high state. Then it start to do next upcoming operations. Next one is your interrupt request. So interrupt request, it is a level triggered maskable interrupt request. So what is the meaning of level trigger in a sense? So in flip-flop, we are already aware of level and edge triggering. This one is your level triggering. Similar to the top level triggering, it has a two types of level triggering. One is a positive level triggering, another one is a negative level triggering. So that is a level triggering. So this one is your positive level and this one is your negative level. And coming to this one is your edge. As the waveform will have a positive edge and negative edge, no? So that is the edge triggering. So level triggering in a sense, once the positive cycle ended means it will meet some 0 point origination. So it will take it into consideration as a positive level trigger. Okay. So this interrupt request will be operated depends upon the level triggered input. So whenever a positive level reached, it started to trigger and it started to accept the data. Next test pin. So this test pin will be examined with the help of wait instruction. Whenever this pin is a low, that is, it holds a value of 0 means the execution will continue. Otherwise, the process will wait in a particular ideal state. Next one is your NMI. Why we are going to see these pins means these pins are addressed in the 8086 40 pin package. So pin wise configuration we are now we are seeing. So first next one is your NMI. NMI in the sense non-maskable interrupt. So non-maskable interrupt, it is also an edge trigger which causes a type 2 interrupt. NMI is a not maskable interrupt which is not hidden internally by the software program. Next one is your reset. This signal is used to reset the 8086. It causes the processor to terminate immediately if in present activity. While doing some activity means whenever you are going to press this reset key means it started to initialize and it started to end the particular process and goes to an initial step. So like if you are going to do in a kit means if you press the RST key means it started to ask the starting address. So it starts wherever it stops in performing the program and it starts to restart its execution. Next one is your clock. So clock signal is necessary for in order to generate a clock pulse. Whenever this clock pulse will be activated, the instruction will be fetched and further transferred to the further process. The clock frequency may be either 5 megahertz, 8 megahertz, or 10 megahertz. It depends upon the version of 8086. Next, we already aware each IC will hold a value of plus 5 volt as a power supply. Whatever the IC may be, it may hold a value of digital ICs will hold a value of plus 5 volt only. Next, the ground pin. It has a, as indicated in the diagram, it has a 2 ground pins. One is pin number 1, another one is a pin number 20. So one is your virtual ground and the other is another one is your normal ground. Next one is your minimum and maximum mode. As I indicated earlier, the pin number 33 will be used as a minimum mode or a maximum mode, depends upon this high-low input. The 8086 will perform the operation of minimum mode or maximum mode. Next, memory input output. This signal will be used to designate whether the processor will perform memory operation or input output operation. Similar to that of write. Whenever if you are in need to write a particular data to the processor means this write signal will be enabled. Next one is the interrupt acknowledge. So interrupt acknowledge, that short form is INTA. When the processor will receive an interrupt request from an external interrupting devices, the processor will again send an acknowledgement signal similar to that of if send a particular letter to a post means you will get some acknowledgement letter, no? So that is the same process. That is, the processor has already received this interrupt request signal. So the processor will going to send us some acknowledgement signal that is indicated with the help of this interrupt acknowledge pin. Next one is your address latch enable. So this address latch enable signal is used to demultiplex the data. So if you are going to give an input means that input can be used to demultiplexed with the help of this ALE. Next one is your DEN. DEN is a data enable. So this data enable will use to inform the transceivers whether this data can be ready to send or the processor can be ready to receive the data or ready to send. Like that, it can be used to indicate that particular process. Next one is your hold signal. So whenever if you are using some DMA, DMA is nothing but direct memory access. You are going to access the data directly from the memory rather than access your internal buses. So while doing that particular process, this whole pin and HLDA pin will be used similar to that of INT and INTA. So INT and INTA is, as I said earlier, interrupt acknowledgement and interrupt request signal. So this hold and hold acknowledgement signal works as same as that of those pins. So depends upon these status signals S0, S1, S2. The operations, whether the read operation or write operation, whether the opcode has to be fetched or memory read or memory write, these kind of operation can be selected. It depends upon these three status signals S0, S1, and S2. Next is a request grant signal. That is a short form. We are going to represent RQ/GT0 and RQ/GT1. So these pins are mainly used by the local bus masters. So these sector signals will be indicated with the help of RQ/grant signal is GT. So these pins are mainly used to make the grant signals. Next one is a log. Whenever if you are going to activate this signal, that processor, consider if a two processor will be used in a particular system, means the data contained in the first processor will not be taken or corrupted with the second processor. That can be performed with the help of this lock signal. That is similar to that of whenever you are going outside the from the home, means you are going to lock with a key. So that operation is the outsiders will not enter that particular room. So that is the purpose of lock. Similar to that of this. Whenever if you are going to lock a particular process, means the data which is present in the particular processor will not be corrupted or taken out with the other processors. So that cannot be accessed with other processor. Next one is a queue status. So during each and every operation, the queue operation will be based on the principle of before, first in, first out. That is clearly explained in the architecture of 8086 in first unit. Depends upon the status signals, the queue operation based will be selected, whether the first byte can be fetched, or you are going to empty the queue, or a subsequent byte from the queue has to be fetched. That can be determined with the help of these QS0 and QS1 signals.